So if you are from Vin's class, welcome. I'm putting the link to the slide deck in the chat. I was just asking the class how many of you have registered for classes, and it looks like 71% about.
I have.
You've registered for classes, Hermione?
Yes.
Okay, good. And then those of you who haven't, the most, so 12% of you too busy, haven't decided what to take, or some other reason. And so glad to see it wasn't just money. That's good. So if you have not registered for classes yet, I would encourage you to do so soon. What happens is during finals week and the week right after, the college sort of decides what classes do they need to cancel because enrollment is so low. And those classes, once they get canceled, they're not going to reopen them. And so if you are thinking that you might want to take something, you should try to get your name on that enrollment list as soon as possible, because I'd hate to have that class be canceled and then you don't have the thing, you aren't able to take what you want to take. Also, sometimes during this last week, or these last couple weeks of the quarter, they look at the wait lists, and if they have wait lists that have like 10 students on them, sometimes they'll open a new section. So even if there's a class that already has a large wait list, go ahead and stick your name on there, because you're sort of voting, hey, we want another section of this. We have people who want to enroll in it. So I would encourage you to get your registered for something. Tuition isn't due until December 18th, and you can get a payment plan. And even if you change your mind, as long as you do it before January 8th, you'll get a full refund. So there is no danger in registering now. Okay, so most of you saw that I have opened up this assignment here called Final Exam Announcement Quiz. This is where you're going to sign up for your time for taking the final exam. So remember, you can either take it in the morning or in the afternoon. And the final exam, you have a window to take it in. So make sure to get that done today. And if you don't, I'll send you an email reminding you. So, but that would be great if you could get that done today. Okay, so let's keep running through the slide deck here. So we went through these two slides last time. These next couple slides, these are just the course objectives for Math 151. These are, basic ideas of things that you need to be able to do. When you're preparing for the final, the thing is that you need to practice, practice, practice. Read your assignments, make yourself practice in a timed setting, because the final exam is a timed setting. So even though you have access to, notes, you aren't going to have a lot of time to go and, search for, things in our class to try to find how to do problems, because it's just that the time window is a little bit tight. So you need to make sure that you can do this without having to do a whole bunch of searching for similar problems for guidance. So as you're doing your practice, if you find that there's things that you're struggling, certain topics you're struggling with, maybe those are ones that you want to make sure to have some notes to remind yourself about how to approach those problems. So make yourself a note sheet as you're going through this, as you're practicing. If you find yourself having to, look stuff up, then this is a good thing to have that already, searched for before that final. Okay, so I have brought some problems to practice with today. And for those of us who are, or those of you who are visiting our class and are not used to my how I run these, I would encourage everyone to just interrupt me when they have a question or you know, you want clarification on something. So feel free to just interrupt. Okay, so what I brought today was I brought a variety of problems that we can work on. So what we have here is we have a related rates. We have an optimization problem. The final exam is not multiple choice. We have find the equation of a tangent line problem. I brought a couple of problems here from the UW Final Exam Archive, and I put the link to that here so you can, these are always good to practice with. So this is one where we're given the graph of the derivative and you have to answer a bunch of questions. And here's a second one. So what would you guys like to work on? So we have related rates, we have optimization, we have tangent lines, and we have given the graph of a derivative, answer some questions, and this is a parametric equation type problem. So vote in the chat. What do you want to work on? Related rates, optimization, tangent line, 1, 2, and 3, some people say, final exam archive problems. So vote in the chat, please. Okay, so let's start with doing parametric and related rates. Okay, so let's start with doing the related rates problem, and then we'll work on some tangent line problems. And we'll do the parametric equation one because that actually is partially a tangent line. And we'll see what we can get from there. Okay, so this is a related rates problem. First of all, how do I know this is a related rates problem? And the way I know that is because they're telling us, well, first of all, we have a cone here. And we have, it's got a radius and a depth of water, and water is flowing into our tank. And we want to know how fast is the depth of the water of the tank increasing at the instant when the depth is 8 meters. So what we're trying to do here is we're trying to find how our height is changing based on how our other variables are changing. So we're looking at how the rates of change are related. So that's a related rates problem. Okay, so first of all, let's try to write down our given information. So our given information, we know that the top of our cone has a radius of 15 meters. So this distance here is 15 meters. And it has a depth of 12 meters. So this distance here is 12 meters. So notice you cannot take anything from the relationships in my picture because this definitely looks smaller than that. But it's actually larger. Okay, and we know that water is flowing into our tank. So we have water coming into our tank, and we know that this is 2 cubic meters per minute. So that's actually a volume. See how it's cubic meters? That's a volume that's coming in. So we know the way the volume is changing, our dV dt is 2 cubic meters per minute. And we want to know, let's see, how fast is the depth of the water in the tank increasing? So our goal is to find how fast the depth of the water. So we're going to need some variables here. So as the water is coming in, you know, whatever our level of water is, this depth here is going, so the water's coming in, so this depth is rising. And we also have this radius here is also going to be changing. So as that water, the tank fills, the radius at the water level is going to change and the depth of the water is going to change. So our goal, if we call this H, our goal is to find dH dt, because we're trying to find how our H is changing when at the instant when the depth is 8 meters. So when H is 8 meters. Okay, so we're going to need some more relationships here because we don't have anything that relates all these quantities. And so one thing that's we see here is we've got this volume, and the volume of a right circular cone is pi over 3 r squared H. So this is our volume of our right circular cone. And so this sort of relates the volume and the radius and the height. It would be nice, since we're trying to find dH dt, and I don't see anything about r, it might be nice to take this and rewrite this so that there's no r. So can we get rid of r? So we can, and the way that we're going to do that is we're going to sort of look at the relationships here between our r and our h. So notice that this right circular cone, it sort of makes, we've got a triangle going on. This distance here is 15 meters. This distance here is 12 meters. And then if we put that water line on the tank, so the water is up to here, and this is changing. So this distance here is h, and this radius there is r. So what we have is we have a similar triangle situation. So if we look at the small height, the ratio of that to the larger height, that would be 12, that should equal the small radius ratio to the larger radius. So what we want to do is we want to get rid of the r because we're only looking at how h is changing. So if we get rid of the r, I could solve this for r in terms of h. R is going to be 15 over 12 times h, which is, if I remove the factor of 3, that's going to be 5/4 h. So I know that my volume could be rewritten as pi over 3 times 5/4 h squared times h, which would give me a volume of, that's going to be 25 pi over, that's 16 times 3, that's going to be 48 h cubed. Okay, so we've done the hardest part, coming up with this formula and knowing what the given information and the goal is. That's the hard part. So now we're ready to just use our chain rule to differentiate this v with respect to t. Okay, I'm not seeing any comments in the chat, like people are confused about anything. Make sure to stop me and ask for clarification if you're getting stuck. So to take this, and we're going to take this formula here, and we're going to differentiate with respect to t. So we're going to get dv dt equals, so differentiating here, we're going to have 25 pi over 48 times 3h squared times dh dt. So there was a question that came in on the chat. So can we solve for h instead of r? You could. The reason why I solved for r here is because we're trying to find dh dt. And so I wanted to put this all in terms of h. I wanted to get rid of the r. So that's why I solved for r. If we solved for h, then this is all going to be in terms of r, and then you're going to have another step. So can we go over how to get the r again? Sure. So what we're going to do, let's do this part again, is we are going to look at the relationship here with the triangle that gets made right here. So there's a triangle that gets made right there. So this radius there is 15 meters, and this height here is 12 meters. That's just from the relationship on that cone. And if we put in that water line, the radius at the water line is r, and the height at the water line is h. And so what we can do, since we've got a similar triangle situation, is to take the ratio of the small triangle height to the large triangle height, that's h over 12, is going to equal the ratio of the small radius over the large radius. And when we take that, we're trying to solve for r in terms of h so that we can put it in right there. And so if you solve for r, you're going to multiply both sides by 15, and we get r equals 15 over 12h, and then you can remove that factor of 3. So that would be 5/4 h. Okay, so everybody good on how we changed this formula here, or this formula here, to be this formula here, so that we got rid of all the r? Okay, so now once we have all of our given information, we've written our formula the way we want it, we have to find dv dt. So I just took the derivative here, and now all I have to do is plug in those values and solve for the goal. So my values that I know, dv dt, that is 2. We have 25 pi over 48 times 3. My h is 8, because they told us h is 8. And then dh dt, that was my goal. So let's simplify a little bit here. Cancel a factor of 3, that's 16. Let's see, we can cancel an 8. That's 2. So we have 2 equals 25 pi over 2 times 8. We have another 8 there, times dh dt. And so dh dt is going to be, let's see, that's a 4. So that's going to be 2 over 4 times 25. That's going to be 100 pi. Okay, so this is how fast our h is increasing. And our units here, remember h is in meters. So our units are going to be meters per second. And you could write that as 1 over 50 pi too. So we would say, as our final step, last step, we would say height is increasing. And I know it's increasing because this is a positive rate of change by I'm going to write this as 1 over 50 pi meters per minute. Okay, any questions? So this is in per minutes here. See how it's per minute there? Per minute here. So this is going to be per minutes here. Okay, so let's go ahead. How did you simplify the bottom? So here, there's a factor, it's 100 in the denominator there. So I can cancel that factor of 2, and that's going to be 50. Is that the denominator you're talking about, Alex? Above that one. This one? Okay, so I'm going to go up here. So what we had is 2 equals 25 pi over 48. We had 3 times 8 squared dh dt. And so all I did was I just started removing common factors. So let's see here. There's a factor of 3 in 48, so that makes that a 16. We could take one of the 16s in 8, that's going to make a 2 there, and that removes that. And let's see, 2 goes into 8 4 times. So now I have 2 equals, so in the numerator, now all I have is 100 pi dh dt. I simplified it in a slightly different way. And then divide both sides by 100 pi, and that's how I get this. And then I just reduced it one more time. Okay, so I'm going to clear the screen and we're going to go on to the next problem. Okay, so the next thing I saw on our list was tangent line type stuff. So this is one tangent line problem, and you've been asked throughout the quarter to find equations of tangent lines like so many times. You should expect that there's going to be something where you have to find the equation of the tangent line on this test. Okay, so looking at this problem, so consider the curve given by the parametric equations. It says find the equations of the 2 tangent lines to the curve at the point 0, 4. Okay, so it might be helpful to graph this just so you can visually see what's going on. And let's go ahead and do that. So if I went into Desmos, so my x of t is t cubed minus 4t, and my y of t is t squared. Whoops. And let's see, let's go from -10 to 10. So here's our curve, and then we're looking at the point 0, 4. So we want to find the equations of the 2 tangent lines at that spot. And we can see that our curve, our parametric equation, causes us to, hit that point at 2 different values of t. So let's first, we're going to have to find 2 different slopes. We hit that point 0, 4 at 2 different t's. So the first thing we need to know, because in order to find the slope of the tangent line, it's going to be in terms of t. So actually, let's go ahead and do that first. So remember, to find the equation of the tangent line, we're going to need the slope of the tangent line. The slope of the tangent line is dy over dx, which when we've got parametric equations is going to be dy dt over dx dt. So dy dt, here's our y of t, dy dt is going to be 2t. Dx dt is we're going to take the derivative of this, we're going to have 3t squared minus 4. Okay, so this is how we're going to find our slope, and there's going to be 2 of them. But in order to do this, we need to know what value of t. Puts us at that point 0, 4. So this is our function. We want to know when are we at that point 0, 4. Well, our x has to be 0. So if we're looking at our x, we're going to have t cubed minus 4t equaling 0. I can solve this. I can factor out a t. Then I'm going to have t squared minus 4. So I have t equals 0, t equals 2, or t equals -2, puts us at x equals 0. And if we look at our y of t, we have t squared has to equal 4. So that tells us our t is going to be 2 or -2. So t equals 0 gives us a different y value. So our 2 values that we're going to get are the ones where we have t equals 2 and t equals -2. So t equals 2, we're going to get, let's call that our m1. We're going to get 2 times 2 is 4 over 3 times 2 squared is 4. So that's 12 minus 4, that's 8. So one of our slopes is going to be 1/2. And the t equals -2, our second slope, our denominator is going to be the same, but our numerator is going to be -4. So we're going to have a slope of -1/2. So our equation of our tangent line, when our slope is 1/2, this point here, this is actually that y-intercept. So we can actually write the equation down without doing any work. Here our equation is going to be 1/2 x plus 4. And here our equation is going to be -1/2 x plus 4. So this is how we do part A. Okay, stopping for questions. So any questions on what we did for this one so far? Okay, so let's move on. So the question is, how can you check on the class recording? So the recordings are all up in Canvas. So if you log into Canvas, then when you go to there's a link to the Panopto recordings, and the class recordings for almost the whole quarter are up there. Occasionally, Zoom will decide that it didn't like the recording. And when that's the case, then we have to, I don't have any way to get it. So I can put this recording into Vin's class for today, but I can't put all of my recordings, but I think Vin has your recordings that you have from her lectures that you can watch from her class, but I can try to put today's in. Okay, so let's move on to question B. So Suppose let g of t be the slope of the curve at time t. So part B, g of t is the slope of the curve. So do we know what our g of t function actually is? Do we have the g of t function already?
dy dx.
Yeah, it's really just this function right here, right? So g of t is 2t over 3t squared minus 4. And so it says compute the instantaneous rate of change of g of t at time t equals 1. So we want the instantaneous rate of change of g of t. So what are we going to have to do to find the instantaneous rate of change of g of t? We need to compute
The derivative of g of t.
Yep, we need to find g prime at 1. So to compute this derivative, we're going to use our quotient rule. So we're going to have 2 times 3t squared minus 4 minus 2t times 6t over 3t squared minus 4 squared, and then you plug in 1. So I'm going to skip that part because I think you guys can do that without my help. Okay, any questions about this problem? Okay, so let's go ahead and clear. And I'm going to go back through the Okay, so let's look at problem number 2 next. So this says we want to construct a cylindrical can whose volume is 105 cubic millimeters. The material for the wall of the can costs $3 per square millimeter, and the material for the bottom of the can costs $7 per square millimeter. Man, this is an expensive can. And the top is $2 per square millimeter. Determine the dimensions of the can that will minimize the cost. So our goal is to minimize the cost. So this is one of those optimization problems. So the first thing we're going to need to do is we're going to need to build the objective function. And in this case, it's going to be the cost function. Second thing we're going to need to do is to find all the critical values. Third thing, we're going to choose which one gives us the min, and we're going to verify that really is the min. And remember, to verify, we have 3 different ways. If we have a closed interval, we could use the extreme value theorem. If we have, or we could use the first derivative test or the second derivative test. And then our last thing we're going to do is state our answer, including units. Okay, so let's start building our cost function, because in this one, that's, you know, a big part of the problem. So we've got a can here. And this can, in order to determine the can, we know that we need to have the radius and we have to have the height of that can. And we also know the volume of cans like this is pi r squared h. And we can look at this can, we can kind of take apart this can. It's got three parts. It's got the top, it's got the bottom, and it's got the sides. And the way that we figure out the sides is we take those sides and we roll them out. So we sort of cut it and roll it out. So the height here is this dimension here. And if we go all the way around here, this distance here is going to be 2 pi r. Okay, any questions so far on
Is
how
2 pi r the formula for the circumference?
Yep. Because if you take and you roll out, if you make a cut right here on your can, the side of your can, and roll it out, this distance around here corresponds to this distance here. And so that's the circumference. Okay, so our cost, when we think about our cost function, we have different costs for different sides or different parts. So we have the cost of the top is $2. So that's going to be $2 times the area of the top. And then we're going to have the bottom costs us $7. So 7 times the area of the bottom. Plus $3 times the area of the side. So we're going to have 2 times the area of the top is pi r squared. 7, the area of the bottom is also pi r squared. And then 3 times the area of the side is 2 pi r times h. So this is our cost function. Now, one thing to note is this looks like it's mostly a formula of r, but there's also this h here. And that h, we can't take the derivative with that h still in there. So somehow we have to get rid of the h. And hopefully you notice that they also told us that the volume is 105 cubic millimeters. So we could use this fact and our volume formula to solve for our h. So we have 105 equals pi r squared h. So h is going to be 105 over pi r squared. So I take that and plug that in right there. Yes, good, Amina. Okay, so let's simplify this cost formula. So this is going to give us, I'm going to combine these two because those are basically the same. That's 2 plus 7, so it's going to be 9 pi r squared. And then if I plug this in here, we're going to have 3 times 2 times that 105. So that's going to be 6 times 105. So that's going to be 630. And then we have pi, and then we have r. And then in the denominator, we have pi r squared. So I can cancel, those are going to cancel, and then one of these is going to cancel. So our cost formula is 9 pi r squared plus 630 over r. Okay, any questions about what we've done so far? Because this is the worst part of this problem. Any questions so far? Okay. So now we've done this, we're ready to move on to finding the critical values. And when we think about the critical values, there's 3 types of them. The one that frequently is what gives us the minimum is where our C prime is 0. So if I took the derivative here, we're going to have 18 pi r minus 630 over r squared equals 0. Well, you don't, it's good to have those formulas for spheres and cylinders and cones memorized, but you guys get to use notes, right? So I might just sort of list those on my note sheet. Okay, so I'm going to move this over onto the other side. We're going to have 18 pi r is 630 over r squared. I'm going to multiply both sides by r squared and divide both sides by 18 pi. And we're going to get r cubed equals 630 over 18 pi. So I need to, Vin's class, I'm not sure what Vin's rules what Vin has for the rules. So you need to consult Vin's class. So does Vin's class have notes for the final as well? See, I don't know. So you should send Vin an email or a message in WAMAP. And she does have Wi-Fi now, so she is going to be able to answer. So our r, all we need to do is cube root both sides. Okay, so this is our place where our C prime of r equals 0. But we also need to think about, are there any other critical values? So are there any endpoints of our domain? So do we have any domain restrictions for r? Did they tell us that the radius or the height of the cone has any restrictions? And they didn't, but we do know that our r just is greater than 0. So if our r is strictly greater than 0, there are no endpoints. Now, if it said r is greater than or equal to 0, then we would definitely have, so if it said this, then I would have r equals 0 is an endpoint. But since I don't have that, we have no endpoints. And then the last type of critical value is where our C prime of r does not exist. And the place where this is not going to exist, here's my function, right? Whoops. Here's my function right here. The place where this does not exist is r equals 0, because that would give us a 0 in the denominator, but this is not in the domain. Okay, so the only critical value we have is that one right there. So if our function has a maximum, it's located here. If our function has a minimum, it's located here. It is really important that I see all the critical values, or that you looked for all those critical values in your work. Many of you on the last quiz got dinged by this because the critical value where your derivative was 0 was outside of the domain. There was endpoints given on that one. So make sure that you look for all these, because unless you look for all the critical values, you will not get full credit. Okay, now, so we've done this. Next, we need to choose to verify. So on this one, there, we have those 3 methods: extreme value theorem, which is not a possibility in this one because we do not have a closed interval. We have the first derivative test or the second derivative test. I probably would do the second derivative test on this one because it would be really easy to calculate the second derivative. So if we do the second derivative of our function, that's going to be 18 pi. And then that's going to be plus 1260 over r cubed. And because our r value is positive, all we really care about is the sign here. If we plug in this value for that's our critical value, this is definitely going to be greater than 0 because we've got a positive number here, and then this is going to be a positive number, so it's going to be greater than 0. So that means we're concave up, and r equals this value. Sorry about my handwriting right now. We're getting into Zoom is starting to tweak on the drawing part. So this is a min. And then the last thing that we would need to do is just write a sentence. And oftentimes you have to look, do they want the minimum cost or do they want the dimensions that give you the minimum cost? And on this one, they want the dimensions. And so you would need to give R and H, and you would just write that sentence. Okay, so that's probably the last problem that we can fit in today. So it looks like Ashley is saying that Vin has said that it's open note, but I will I encourage you to email Vin about that, and I'll ask Vin to post a message in your class just to clarify. Before I clear this screen, does anybody have any questions? So Amina, it can't be less than 0. So what can't be less than 0? Oh, you were probably answering a question that I had already asked and I missed your answer. Okay, so let's go ahead and clear that. And then I want to just go back to the reminders. So I need everybody, in Vin's class, you're doing this too. You need to go and sign up for your exam time in this final exam announcement quiz. Okay, so I want to thank everybody for coming on this last day. My class, could you please write here in the chat so that I can record attendance? And I want to say that I have enjoyed teaching all of you, and this has been definitely a new experience. I've never done a synchronous class online, so I appreciate you guys experimenting with me.